Two boat engines, same horsepower, same size, but one is built to last for decades while the other is built to dominate right now. So what really makes Japanese and American marine engines so different? This difference wasn't accidental. It was engineered. And once you understand why, you'll never look at boat engines the same way again. To understand this story, we need to go back to the moment boats stopped being simple machines and became symbols of power, speed, and national identity. After World War II, both Japan and the United States faced the same challenge. They needed engines, reliable engines, powerful engines, but they answered that challenge in completely different ways. In the United States, marine engines evolved from abundance, large rivers, open oceans, cheap fuel, and a culture obsessed with horsepower. American manufacturers didn't ask how little they could use. They asked how much they could build. Early American marine engines borrowed heavily from automotive designs, especially V8s. Big displacement, heavy cast iron blocks, low revving torque. They weren't elegant, they were dominant. Bigger pistons meant more torque. More torque meant heavier boats. Heavier boats meant stability, and stability meant confidence. These engines weren't built to be delicate. They were built to survive abuse, missed maintenance, saltwater exposure, long idle times. They could take it. And if something broke, you didn't replace the engine, you rebuilt it. American marine engines were mechanical, loud, physical. You could hear them, you could feel them. They demanded respect, but they rewarded strength. Japan had none of those advantages. Fuel was expensive, space was limited, and post-war industry demanded efficiency above everything else. Japanese engineers were forced to ask a very different question. How do we get more with less? Instead of displacement, they focused on precision. Instead of brute force, they focused on balance. Tighter tolerances, higher revs, lighter materials, cleaner combustion. Japanese marine engines weren't designed to overpower the water. They were designed to work with it. Every gram mattered. Every vibration mattered. Every potential failure point was studied, tested, eliminated, and redesigned. Where American engines relied on strength, Japanese engines relied on control. By the 1970s and 80s, these differences became impossible to ignore. American engines sounded aggressive, deep, heavy, confident. Japanese engines sounded smooth, controlled, almost surgical. American manufacturers prioritized accessibility. Parts were large, designs were simple, repairs were straightforward. Japanese manufacturers prioritized consistency. Engines were harder to rebuild because they rarely needed to be rebuilt at all. This wasn't coincidence, it was culture translated into metal. One of the biggest differences came down to how failure was expected. American marine engines often assume maintenance. They assume the owner will check oil, replace components, and fix problems as they appear. Japanese engines assume the opposite. They assume neglect. That's why Japanese engines often feel overbuilt in subtle ways. Better seals, conservative tuning, extensive testing cycles, not to impress but to prevent failure. Japanese engines are often detuned from their maximum potential. They're not chasing peak numbers, they're chasing longevity. American engines, on the other hand, often operate closer to their limits. They're designed to deliver power immediately, even if that means higher stress over time. Speed versus endurance. That's the real divide. American marine engines love short bursts of power, acceleration, top-end pull, immediate response. Perfect for speedboats, performance cruisers, and heavy load applications. Japanese engines prefer sustained operation, hours at consistent RPM, minimal heat buildup, minimal stress, perfect for fishing boats, commercial vessels, and long-distance cruising. Neither approach is better, they're just built for different lives. Environmental regulations also played a critical role. Japan adopted strict emission standards early. That forced innovation, cleaner combustion, efficient fuel delivery, advanced engine management systems. The United States responded later, often adapting existing designs instead of starting from scratch. That's why Japanese marine engines were quicker to adopt electronic fuel injection, compact layouts, and advanced cooling systems. Constraint created creativity. Nothing reveals engineering philosophy like failure. When American engines fail, they often fail loudly. Broken components, visible damage, obvious wear. When Japanese engines fail, it's usually subtle. Sensors, electronics, preventive shutdowns. One system sacrifices parts, the other sacrifices operation. Both are designed to protect the core, just in very different ways. This difference is felt most clearly by the owner. American engines feel mechanical. You interact with them, you adjust them, you listen to them. Japanese engines feel invisible. They simply work, quietly, reliably. Until one day you realize how many years have passed and they're still working exactly the same. The real turning point came when global markets collided. Japanese engines entered American waters, American engines entered Asian markets, and suddenly, customers had a choice. Some loved the raw power, others loved the reliability. Sales numbers told a clear story. There was no single best engine. There were only engines built for different philosophies. That realization changed marine engineering forever. American manufacturers began focusing more on efficiency. Japanese manufacturers began offering more power. The gap narrowed. But the DNA never disappeared. Even today you can still hear it, you can still feel it, you can still tell where an engine comes from just by how it behaves under pressure. So, what really makes Japanese and American marine engines so different? It's not horsepower, it's not technology, it's not even reliability, it's intention. One was built to dominate the moment, the other was built to survive time. Both are brilliant, both are flawed, both tell a story. And that story is written in steel, fuel, and salt water, because in the end, every engine is a reflection of the people who built it, and the ocean always remembers the difference.